So good evening to everybody, to Friends of UCT Chemical Engineering, with wide-ranging associations from being staff and students, both past and present, to being sponsors, clients, supporters, and members of the broader community. Some of you are here with us, physically present with us. Others of you are joining us virtually from around the world. Many thanks for joining us, and welcome to all of you. For those of you who don't know me, I'm Professor Sue Harrison. I'm currently DVC Research and Internationalization. I joined the UCT Chemical Engineering Department 30 years back as a young senior lecturer, and I continue to be part of and director of one of Chemical Engineering's 5 main research themes, and so it's a space that I still call home, very much call home. So welcome to this celebration of 100 years of chemical engineering at UCT. It's quite some time to have been educating and training those set out for a career in the process industries in South Africa. And we also know that chemical engineers don't stick to the process industries, and they're found around as leading figures in the industrial and commercial sectors, key players in the financial sector, entrepreneurs, farmers, and many other contributing roles. The process industries have been key to South Africa's growth and development, and we celebrate that. They've also played their part in societal inequality and environmental burden, and we acknowledge that, and that strengthens our commitment to be part of a future in which economic contribution, environmental stewardship, good governance, and social responsiveness form a well-balanced framework on which to build our country and on which to build our discipline. So I look forward to continuing to play a part of this. This evening we have a wonderful lineup of reflections. Not sure what that was. But I think we're all safe, aren't we? Right, so this evening we have a wonderful lineup of reflections, both back into the past and forward into the future. They're shared by current members of the department, by past members, by friends of the department, both in South Africa and abroad. For those of you who are joining virtually, please use the MS Teams chat for questions and comments, and we'll be recording all of these and we'll respond after tonight's event rather than on the spot. So let's head into our lineup now, and I'd like first to welcome our first speaker, who's not here in person. Professor Mamokgethi Phakeng is the Vice Chancellor of the University of Cape Town, and she'll provide a reflection of the transforming face of chemical engineering in video format. So we're over to Katie.
Hello everyone, Dumela, Sanbonani, Molweni, and halala to all of you on reaching this historic milestone. It took 48 years after UCT's chemical engineering program was established in 1920 for the first female student to graduate. But you have certainly made up for it since then. Today, you are an exceptional example of transformation, diversity, and inclusion. This year, as ChemEng marks its 100th year anniversary as a department, almost half of your 649 registered undergraduate and postgraduate students are women and 65% are Black. These statistics speak to your vibrant culture as well as the foresight and courage of your leaders over the years who committed themselves to being the change. Over the past century, ChemEng has built on the work of strong and talented people, including Professor Alison Lewis, the Dean of the Faculty of Engineering and the Built Environment and former head of ChemEng, and Professor Sue Harrison, the Deputy Vice Chancellor for Research and Internationalization, who also once headed ChemEng. Professor Lewis is, of course, also the first female Dean of EBE at our university. She entered UCT as a first-year undergraduate student in the department in 1981, one of only 5 women in her class of 50. Ahead of her were a sprinkling of senior female students and a single female academic staff member, Dr. Masami Kojima. ChemEng at UCT in 2020 is a completely different place, thanks to Professor Lewis and a long history of other department heads, lecturers, and students who have helped to make courageous and meaningful advances towards transformation in terms of both gender and race against daunting hurdles. Engineering, after all, has a notorious attrition rate. According to the Council of Higher Education, as many as 50% of students drop out before graduation. In the mid-1980s, when the department's classes were largely white and male, graduation rates were already low, and outcomes for new enrolled Black students were even more discouraging. 30 years later, not only were undergraduate enrollments up, but white students comprised less than 40% of the total number of South African students in the program. By 2011, the program boasted an overall graduation rate of nearly 70%, with dramatically improved rates for Black students. I have asked both Professor Alison Lewis and Professor Sue Harrison to explain to me, how did this happen? Well, a group of key people refused to accept that low success rates in engineering were inevitable. Initially, the interventions in ChemEng focused on teaching methodology, broader mentorship through improved tutoring models, fostering community identity, and student counseling. Today, the department has a radical new curriculum and is meeting the challenges presented by the demands for interdisciplinary research in projects such as the African Climate and Development Initiative. The people of ChemEng show a deep dedication to making a difference where it matters most, in sustainable development, be it societal, environmental, or economic. This department has blossomed not only in size, but in stature, and it's all thanks to its strong staff complement. Only 2 decades ago, the department had just 2 professors on staff. Now it has 11. Over the same period, the number of UCT academic positions increased from 12 to 14, supplemented by a further 17 externally funded academic staff positions. Professor Lewis gives credit to ChemEng's strong bonds with industrial partners, sponsors, and other organizations. This is evidence of the department's high reputation. I want to congratulate each and every one of you, staff, alumni, students, who have helped shape ChemEng at UCT into the internationally recognized department that it is today. You are leading and shaping a field that is absolutely critical in the search for solutions to myriad global challenges such as climate change, energy security, water, housing, and healthcare. I salute you for your past, present, and future contributions.
Well, in her absence, thank you very much, Ketty, for those kind words. And I think we can all take a bow, because everybody in this room has some connection, and probably most people online, with ChemEng and with having achieved what has been described there. I think we can be proud of what we've done. We're going to move on now, and next up is a walk down memory lane, and I'd like to welcome Professor Cyril O'Connor, who has been my boss through most of my working life, not the last couple of years, but most of my working life in whatever form. And he'll take us through a walk through the department's history. Cyril, over to you. Oh, sorry, Cyril, before you come, I've got to say a few more things. So I'd like to introduce Cyril. Cyril is Emeritus Professor in the Department of Chemical Engineering. He is the longest standing member of the department, having been at UCT for over 40 years. He has been both head of department and Dean of the Faculty of Engineering and the Built Environment. He is the founder of the Center for Minerals Research and the founder of the Institute for Catalysis Research, the 2 largest research groups in the department. Cyril, thank you.
Thank you, Sue, for your kind introduction. Madam Deputy Vice Chancellor, Madam Dean, who apparently is on leave. I didn't know there was any such thing as leave, but apparently it's popped out during COVID. Distinguished guests, chemical engineering colleagues and students, ladies and gentlemen. Firstly, may I thank you all most sincerely for kindly joining us today, either in person or virtually, to celebrate this wonderful centennial milestone in the history of chemical engineering at UCT. I wish immediately to thank Jim Petrie and Jenny Case for the huge effort they've put into ensuring that this most important event, not only in the history of chemical engineering at UCT, but in the history of the discipline, both in South Africa and indeed globally, is celebrated in an appropriate manner. I also wish to pay tribute at the outset to those truly outstanding individuals who have gone before us and who certainly in the post-World War II period, which we may call the Donald Carr era, laid the foundations for what is today a department with an outstanding reputation and known globally for its excellent research and teaching and the high quality of its graduates, many thousands of whom who have gone on to illustrious careers around the world. In this context, of course, I am reminded of and pay tribute to the seminal contributions of people such as Donald Carr, the first head of the fully fledged department, Ernest Prout, under whom I did my PhD, Jeff Hansford, Brian Padden, Duncan Fraser, Granville de la Cruz, and many others, sadly all now passed on. But then also of the equally high and huge contributions of many people who thankfully are still alive and well and who have in different ways joined this celebration today. And I especially am reminded of Heinrich Boer, John de Kock, Sidney Miller, J.P. Franzidis, Bill Randall, and many others too numerous to name. And of course, it is fitting to recognize at the same time the major contributions of the wonderful past and present administrative and technical staff. It is in fact impossible to overemphasize their enormous contributions to the success of this department. We thank them all for their huge contributions to the long-term and ongoing success of the department. I have wondered at some length on what to say in these few minutes regarding my thoughts on attributes to which we could ascribe the success of the department over the past 100 years. And I have been thinking that it is in many ways reflected in the outstanding culture of what I will call research-led teaching. This frequently used phrase has been extensively explored in many case studies globally, but I would like to briefly unpack this concept and how, as I see it, this department has given expression to that culture. Research-led teaching, in my view, very simply means that any academic teacher must be actively engaged in some form of research to be an effective teacher. This does not mean that to teach, for example, heat transfer or reactor design, the lecturer needs to be engaged in research related directly to that subject field, but rather that by being engaged in research, an academic develops an inquiring mindset, which results in her or him always wanting to ensure that their students are beneficiaries of the cutting-edge concepts in the subject being taught, thus ensuring that when they eventually graduate, they are equipped with a world-class relevant toolbox to take with them wherever they go. And a key component of that toolbox is an inquiring mind, capable of lateral, out-of-the-box thinking, which is probably why so many of our graduates have gone on to distinguish themselves in many fields other than just the core discipline of chemical engineering. The Centenary book is indeed permeated with such examples. And continuing on this theme, what do we mean by research-led? One of the distinguishing characteristics of being a university-based researcher, as opposed to a person engaged in research in, for example, an organization in the public or the corporate domain, is that the university-based researcher is actively engaged in supervising postgraduates, without which university research is almost meaningless, as well as, of course, subjecting their research to peer review. Universities all over the world consider supervision of research students as a teaching function, because this is a core activity for an academic. And indeed, one of the most satisfying academic aspects of an academic career is working with postgraduates as they grow and develop while they push back the frontiers of knowledge in their particular research area. And in so many ways, postgraduate students are the epitome of what is meant by research-led teaching, since while engaged in their research, they are also actively involved as tutors in different courses. Indeed, it is fitting to recognize at this time the almost 1,000 postgraduates who have gone through this department over the past century, for in so many ways their achievements and successes represent what this department is all about. And so in my view, what has always characterized this department's ethos and contributed hugely to its success is that every member of the academic staff is actively engaged in supervising research students and publishing their work, while at the same time, everyone is carrying a solid teaching load, with the top researchers often indeed being the preferred lecturer in the junior undergraduate courses. Finally, ladies and gentlemen, in developing this theme of ascribing the department's success over the years to this research-led culture, I can hardly think of better exemplars of what I am talking about than to refer to three outstanding individuals, all of whom are members of the Department of Chemical Engineering. I refer, of course, to Professor Sue Harrison, the Deputy Vice-Chancellor for Research, Professor Alison Lewis, the Dean of the Faculty, and Professor Aubrey Mainza, head of this very large and complex department. The reason why I present them as exemplars of what this department is all about is that it is noteworthy that all three, while carrying key and onerous research leadership positions in the university, nonetheless continue to remain at the forefront globally in their respective research areas. And I do not make that statement lightly, since I know that all three enjoy outstanding international reputations in their respective research fields. They are shining examples of what this department is all about and what makes it successful. May I close, ladies and gentlemen, by expressing the wish that the current and the future generations of chemical engineering staff and students will continue to embrace the culture which has characterized the generations who have gone before us, namely of ensuring that the department continues to enjoy a world-class reputation for its research, which will ensure that its students receive only the highest quality education. This is not a trivial challenge, but one which must be embraced so as to ensure that the next century of chemical engineering at UCT will be even more successful than the last 100 years have been. Our congratulations, therefore, thanks and appreciation to all those staff and students who over the past 100 years have contributed in one way or another to the great success which this department has enjoyed. Many of them may be gone, but none of them are forgotten. Thank you.
Thanks very much, Cyril, for those kind words. I think that you make a hugely important point, and following on from Mamokgethi's video, the linking the research-led approach of chemical engineering and the very close relationship between research and teaching with what the department has done over those years. We can't ignore, though, that for most of us in this room or in the department of my generation, we were mentored by Cyril. So Cyril has played a huge role in this, and those of us who are now mentoring others were taught to do it by Cyril. So thank you very much, Cyril, for both your words and for what you've done. So next up, I'd like to welcome Dr. Christine Render. Christine has 38 years experience as a chemical engineer. She started up and led SASL's concept development function for more than 10 years. And following this, she was executive manager engineering for SASL's capital projects. Christine has been associated with the department through SASL supported research in the Institute of Catalysis Research and as a member of the Departmental Advisory Board. She will relate experiences as part of a key sponsoring company as a key employer of our graduates and as a member of our advisory board. Thank you, Christine.
Thank you, Sue. Good evening, ladies and gentlemen. It's a pleasure and an honour to be here to participate in the celebration of the Chemical Engineering Centenary. I am a chemical engineer, as Sue has explained, 38 years towards the end or the latter part of my career in industry. Of those 38 years, 27 was spent at Sasol. During the time when I was the head of engineering on capital projects, I was asked to participate on the advisory board at the University of Cape Town Chemical Engineering Department, together with other industry representatives. And that's my main link with this department. At the time, I Minister respectively. There were probably 10 or 12 industry participants on the advisory board, covering a range of industries, South African breweries, NGen, trying to think of the others, but across mining, chemicals, refinery, and we met annually and discussed a number of topics. I was on the board for about 10 years, 2004 to 14. We covered, and I was very impressed with the commitment of the staff of the university in ensuring that they offered the best in teaching and research that they could. The sort of topics we addressed in the undergraduate side of things was the gaps in the curriculum, any topics, any new topics that needed to be included in the curriculum, changing demographics, transformation, staff to student ratios, departmental budgets and funding, and so on. The agenda also covers, of the advisory board, also covers progress on research areas within the department, achievements, future direction, staffing levels, etc. In short, we as industry representatives were invited to comment and give input in order to ensure that the UCT Department of Chemical Engineering remains current, relevant and world-class, turning out world-class graduates and academics in demand by industry and institutions in South Africa and abroad. Throughout my tenure on the advisory board, I was indeed impressed by the willingness of the department to seek external input and advice in order to improve and remain world-class. In general, I believe the fundamental core of engineering education in South Africa is world-class, and for the past 100 years, University of Cape Town Chemical Engineering Department has been one of the leading educators of chemical engineers, and I believe this will remain so for the next 100 years. Thank you.
Thank you, Christine. Thanks for your insight there, and thank you also for being here tonight and for the time you've given the department over the many years. I think that's something which has been really special to chemical engineering, is that we've had sponsors who've given us time to advise us, time to work with us in our research, and time to think about who we graduated to prepare them for the workplace. Thank you. I'm going to move on now to consider a broader perspective of the reach of chemical engineering, and I'd like to introduce Professor Dave Walwyn to bring his experience in academia, in industry and government, as well as in future trends. So David is professor at the University of Pretoria in the Graduate School of Technology Management, and he's the director of Rethabile, a research management consultancy. He graduated from the Department of Chemical Engineering in 1979 and completed a PhD at Cambridge. He's had various roles in industry and government and academia, including Chief Commercialization Officer at Itembo Pharmaceuticals, Chief Executive Officer at Avira, tongue-tied, Technologies, and Research Group Manager of the CSIR. In fact, Dave was the industrial liaison of my first research grant from AECI back in 1991. Dave, over to you.
Thank you so much, Sue. And I honestly can't remember that, but I hope I was very kind. If you can tell me afterwards. Well, there you go. That's a good start. So Deputy Vice-Chancellor, colleagues, present and ex-members of the department, present and ex-members of the student cohort, greetings. It's a great pleasure, of course, to be here and to participate in this event and be part of this broader congregation of attendees who at some stage in their lives have been connected to the Chemical Engineering Department at the University of Cape Town. Thank you especially to Jim and the organizing committee. It's pretty obvious, but I'm not an Elon Musk or a Christo Wiese or a Koos Becker. None of them were chemical engineers. But over the last 40 years, I've worked in big firms, as Sue was indicating, medium firms, tiny firms. I've worked in government, in universities, in a science council, in public-private partnerships, and in NGOs. You could say that I have a rounded, perhaps even blunted perspective. But over all this time, my chemical engineering degree from UCT has stood by my side and been useful in ways that I never even possibly imagined. So when Jim asked me to talk today, of course, I readily agreed. Then he told me what he wanted me to say, and I'm going to tease Jim a little bit now. Please cover the structure of the South African industry, which sectors might benefit from innovation, the role of chemical engineers as innovators and entrepreneurs, how this can be accomplished through the university, industry, government access, and what more should be done to foster networks. All in 10 minutes, and one last request. Please make it humorous. All of this is true except for the last. So firstly, congratulations to UCT Chemical Engineering. The course in the first course in Chem Eng I read was given by George David at the University of Manchester in 1887. And in the wider scheme of things, UCT was not long thereafter. It's a massive achievement. Well done to the department and the university. A century is an achievement in two important respects. One, just being alive. The other is it implies an ongoing relevance to the present. And in my brief contribution, I'm going to talk about the relevance issue and particularly how it forms the basis of a strong, healthy university, industry and government relationship. At the moment, I'm working mostly in the field of sustainability transitions, not heavily connected with chemical engineering, has to be said. But in simple terms, this work deals with how we can accelerate the transformation of socio-technical systems, including energy and mobility, to be more sustainable. One important concept in this field is the notion of pathway dependence or recalcitrance to change or incumbency. All these refer to the same pattern that institutions become locked into existing strategies and relationships, which serve their present interests and act by default against new actors or new ideas. In short, institutions become inflexible and indeed less relevant over time. And the theory of this pattern, quite appropriately, is known as historical institutionalism. UCT, chemical engineering, in my view, has avoided this trap. The key for this talent, and that was very much part of the talk that Cyril gave, is the contribution of the staff. It's partly the nature of the university, which is to lead public thought, but definitely a large part to do with the staff. And as long as I can remember, and that's now almost 50 years, the staff have ensured strong ties with industry, strong international ties, and a vibrant link to their community of students. Students also form an important link between universities and industries, and I call that the link of two feet. The flow of students from final year to employers. Ideas at university do indeed make their way into industry through the students, on occasion quite quickly and very vibrantly. So I'm now going to give you some examples from my own career of this technology transfer, just as a reflection really on university-industry relationships. After graduating, I worked for a small fermentation company which produced ethanol from molasses, an age-old process. During my time at the company, I used design approaches developed with Jeff Hansford, interestingly, to reconstruct the fermenters and lowered the cost of ethanol production by 20%. We also started work with University of KwaZulu-Natal in the mid-80s to develop alternative approaches to the company's waste treatment. And that's a whole talk on its own, but it was based on insights from a course on wastewater treatment, which I'd done with George Ekemer and Prof. Morel. In the 90s, when I was working with AECI, there was a similar project, and in fact, in the 80s as well, as the DVC has just told you, there were similar projects with universities, including a project between AECI and MIT on the optimization of lysine fermentation, between AECI and WITS on fermenter control using Kalman filtering, and of course between AECI and UCT on a range of projects covering novel strategies for the design of algal bioreactors, the development of novel chemical catalysts, research into biocatalysts for the production of pharmaceuticals, and many others. And there are two people here today, obviously Professor Sue Harrison and Professor Stephanie Burton, who are very much involved in that work. The joint work was never really about outsourcing R&D to a low-cost environment. And this is one of the fundamental points I want to make about this university-industry relationship. In fact, I don't think outsourcing was in our lexicon in those days. It was much more about creating absorptive capacity in both the universities and the industry and training human resources in a relevant field. It was about new ideas, technology transfer, and about innovation. It was a relationship which served multiple purposes and was filled with a recursive set of exchanges. In other words, it was a network, which then brings me to the university government industry access that Jim has asked me to talk about. There is a powerful concept in science and technology studies which is known as performative discourse. Essentially, it refers to the way in which the stories we tell and read each day become self-fulfilling. They result in the action that you talk about. So if you think and talk in a particular way, it begins to shape the way in which that sector is acting. And it's particularly true of relationships between different sectors. All too often we hear that public servants are interested in neither the public nor service. They are incompetent and corrupt. The private sector is only interested in plundering public goods and exploiting workers in order to amass huge fortunes which they quickly move offshore. The universities are full of unkept theoreticians with no understanding of or interest in the real world. Although sometimes these stereotypes are indeed validated by actual examples, my experience has been that when you open the doors to the offices, you find real people who are honest, who are sincere, and who want to do their best for their communities. I started with the issue of lock-in and incumbency. I noted that the department had been able to avoid this trap. The extent to which individuals influence the direction of institutions is probably the oldest and most contested debate in the social sciences, and it's called the structure-agency debate or dichotomy. So I'm going to talk very briefly about that. Agency is just another term for being able to act in a way that shapes your world. I have agency if I decide to do something, and the only barrier is my own energy and determination. Structure is what exists outside of me. It is what mostly stops us from being what we are, what we would like to be in the world. In reality, only the very powerful have complete agency. The rest of us are constrained to various extents by the societal and economic structures within which we are located. Structure agency also is not a binary. It is a spectrum along which we are placed as a consequence of education, gender, race, class, and identity. So I mentioned structure agency not to confuse you with some social science, but because the question of agency was also very important to me in the academia-industry relationship. Although less evident now, it is generally true that university professors give up their ambition to earn directors' salaries in exchange for being able to pursue their own interests and hopefully to pursue a value-based existence. Jim, for instance, was not only interested in environmental research, but he worked in this area because it was the right thing to do. Such choices are not often possible in industry. In terms of the employment contract, and this I'm very familiar with, you become the agent and your employer becomes the principal. You sign away your right. It was this axiological aspect which, in my view, is important in the university industry relationship. If academics cannot be honest in their relationship with industry, and especially private capital, then who else can be? When I worked in industry, my relationship with the university was a moral compass. It was the only means through which I had to proportion my world within the broader horizon of social and environmental justice. And I think this is a very fundamental aspect of that university, industry, government access. Which brings me to my last point, and one in which I want to take with you into the future. Universities have now an even more critical axiological role to play in driving changes to our socio-technical systems. In my piece in the Centenary publication, I made a passionate plea to future graduates to adopt the Sustainable Development Goals as the new normative framework, as your guiding compass, no matter how difficult this may seem. Changing mining, manufacturing, energy generation, and other economic activities to be more sustainable require all of us to exercise agency and to use our capability to shape the world. So Jim asked me for some suggestions on opportunities for new chemical engineering graduates within the South African economy. And my view is these are aplenty, but none of them are simple. Unfortunately, and this is probably one of the most painful things to reflect upon in the last 50 years since I graduated at UCT, is the deindustrialization that's happened in South Africa and the declining contribution of manufacturing to the economy. So let me inspire you with some things which I think if you are at the start of your career, go out, raise some money and do. And these are the list in no particular order: energy storage products and the whole value chain, the manufacture of components for photovoltaics, the panels themselves, and the whole value chain. Anything to do with LEDs, phosphors, and lasers for lighting and communication applications, all of which have got chemical components which are made through chemical engineering. Processes for recycling and equipping the circular economy, including separation equipment for precious metals and plastics, becoming a very, very important component of any transition to a circular economy. And finally, not to leave out pharmaceuticals, diagnostics, and vaccines, which have been so much in the news this year. This is an area in which I've expended a great deal of energy and in return received nothing but lots of hard lessons, but perhaps one or two successes. And perhaps that's an area which will be of interest to entrepreneurs and innovators. In conclusion, we are facing not just the prospect of climate change, but the real likelihood of climate breakdown. In many cases, you and your students will bump against your heads against structure, and this is addressed obviously to the department, will bump your heads against structure, deeply embedded norms which resist change. To the existing faculty, to the recent graduates, to the present students, to the students of the future, I have one simple message. We need your ethical and technological leadership and agency in taking forward SDGs. Strength to you all. And in the words of Darth Vader or Star Wars, may Mother Earth and UCT Chemical Engineering be with you. Thank you so much.
Dave, thanks very much. Always known to challenge us, and we like it. So thank you for that. And thanks for all the the innovation side of UCT as well as an advisor, and we appreciate it. Thanks, Dave. So it now gives me great pleasure to introduce Professor Hamieda Brey Parker, somebody who I remember very strongly from my early days in the lecture theatre, lecturing mass and energy balances and bioprocess engineering. Years later, I discovered that Hamieda and I were also at the same high school. So Hamieda is an associate professor at the UCT Graduate School of Business and is chairperson of the GSB Transformation Forum. She graduated from the Department of Chemical Engineering in 1992 and then completed an MBA and a PhD at UCT. She has worked in industry as a practicing chemical engineer and in academia, where she specializes in operations, supply chain management, entrepreneurship, innovation, and new product development. Thank you, Hamieda.
Good afternoon, everyone. It was suggested that I talk about my personal journey, and standing here, I have to laugh. So I've been on the faculty of the GSB for the last 20 years, and I was actually born across the road at Somerset Hospital. So in distance-wise, I actually haven't journeyed much. I remember on day one of first year chemical engineering, Prof. Cyril O'Connor showed us all the statistics. The number of students that will drop out, those that will fail, and I was really scared. But I think he did a very good job in setting the tone for the degree. The work ethic, the very strong work ethic that I developed over the 4 years of chemical engineering has stood me well and well beyond my degree. Looking back over my degree, I feel that the chemical engineering degree gave me a solid foundation in process analysis, mass and energy transfer, thermodynamics, reactor design, process control, and more. And this foundation served me well in the workplace. But more enduring than these particular areas was that I learned to work really hard. That I learned to work efficiently in a team. And that I learned to be kind. Being a proficient engineer is not enough. To be a good team worker and to be a good work colleague, one needs to be kind and caring. Engineers often get assigned leadership roles in the organizations that they work. And being able to lead with kindness is a quality that I really hope we are able to establish within our engineering graduates. It is on this point that I feel honored to be associated with the UCT Chemical Engineering Department, as I have experienced caring leadership from all the faculty that have taught me over these 4 years. I recall as a second year student being given a VAC project on heat exchange analysis, and we hadn't covered this in second year. So I desperately reached out to Prof. Fletcher, who without any hesitation sent me the requisite material to work on this project, this in his December holidays. I also remember struggling to set up my experimental apparatus in my final year project thesis. I was attempting to measure chlorine in an airstream once it had passed through a bed of calcium carbonate, limestone. This was to investigate the efficacy of using limestone to remove harmful chlorine from incinerator flue gas. The gas passed through a column of water, and I needed to measure the chlorine concentration within the water. For days, I was picking up nothing, 0. Then Prof. Hansford passed by and in his normal, casual way asked me how I was doing. I explained my dilemma to him. He came over, he looked at my setup and asked me one question. Is the residence time of this gas sufficient? One question, and everything was clear. I realized that I did not have sufficient residence time for this gas to be able to measure the concentration accurately. We experimented with a number of different types of Raschig rings, and eventually, voila, the apparatus and the experiment worked. During project thesis, Prof. Jim Petrie introduced me to doing good research, and his encouragement through the project really sparked my interest in research. I also recall Prof. O'Connor and Prof. Sue Harrison encouraging me to apply for doctoral study and scholarships in chemical engineering. For me, the kind-hearted way chemical engineering faculty shepherd their students to paths where they can reach their full potential is admirable. And in many ways, their kindness is what inspired me to serve in the academic role that I currently now have. In reflecting, I thought it would be useful to share some of my work my students and I are doing in exploring new research areas. We are currently looking at how organizations in the banking and financial institutions and industries are implementing robotic process automation, artificial intelligence, and how blockchain is impacting supply chain management. How supply chains, particularly in the food industry, can be made more sustainable. We have also been looking at resilience, and we did studies to examine how firms could develop resilience in the face of electricity and water supply disruptions. This research has taken on a new relevance now that we are looking at how firms can stay resilient during this pandemic. The research that has, however, really changed my thinking the most has been the work I have been doing with my student at a large hospital on the Garden Route. Here we looked at psychological safety, team learning, and team performance. We found that as psychological safety in the environment increased, the propensity for teams to learn increased, and so in turn did their performance increase. It says a psychologically safe environment is an environment where everyone feels safe to speak, to voice a concern, or to ask a question. It has been found that it is sometimes difficult to create an environment of psychological safety where there are entrenched hierarchies or prejudice. For example, in hospitals where nurses will not question a doctor, or in manufacturing environments where a worker on a line will not question a manager. Prejudice and discrimination in the workplace create fear, and this causes people to feel unsafe. A study done on a large sample of hospitals showed that in those hospitals where an environment of psychological safety was created, medical errors are lower. There are numerous examples where, for example, a nurse feels that she cannot question a doctor's instruction and a patient receives an overdose of medication, or there's a wrong side surgery, or in the worst case, death. In manufacturing, if workers on a line are not able to express their concerns about process or equipment, firms could face huge losses without understanding the cause of the problem. In the last few days, I received 2 calls which made me feel that we are not doing enough to create a psychologically safe environment at our university and in industry. The first was from one of our students on a master's program. I don't know her, but she called me as I'm the chairperson of the Transformation Forum here at the business school. And she wanted to talk to me about how she felt discriminated against for her race and her age. I feel that she's courageous to come back to do a master's despite being almost double the age of her class, and I listened with much sadness as she went on to explain how racial and age-related slurs were being made against her in the chat box during class discussions. The second student is my research student, and I know her well, and she called me on Thursday. She is working for a multinational manufacturing firm that is operating on a 24-hour basis, and they had to increase their production over the lockdown period because they are producing essential items. Despite working under stressful conditions, herself contracting COVID, she has not missed a single deadline. She is strong. But on Thursday, when she spoke to me, she was broken. As the only woman of color on an all-white, all-male senior management team, she was being attacked for her process analysis findings, which highlighted several issues that needed to be addressed within the plant. As she spoke, I was in tears as I relived the discrimination I faced as a new graduate chemical engineer. I was a person of color, and I was the only woman engineer on a plant of over 2,000 people. And it was tough, really tough. I had this experience in 1993. It is now 2020, and it seems almost impossible. And yet, this is what our students and graduates are facing now. We have managed to leap far ahead with new technologies, and yet we have not moved forward with transformation. People of color, especially women, are still experiencing discrimination in its worst form, and we need to do something about this. For people to learn, they need to be in environments where they feel safe. For managers in industry, it is critically important to hear every voice. A worker on a line that highlights a problem could save a firm thousands, if not millions of rands. I've personally seen the value in listening to the suggestions of a line worker or a machine cleaner at the plant that I worked. But that worker or that cleaner will only speak if he or she feels that the environment is psychologically safe. My call to all of us at this university and in industry is to critically examine the environment and to speak to people within your departments. Give them a survey if you need to, but rather speak to them. Find out what makes them feel unsafe, why they are not speaking. We need to hear everyone's ideas to be innovative, to develop the best products, and to improve. Psychologically safe people are engaged in their work. They are motivated to give their best. By harnessing diversity and creating an environment where everyone feels empowered to express their ideas, we can create organizations where people truly thrive. My challenge to you is to create these environments where people can thrive, where they can work hard, be effective in teams, and be kind. I'm really, really passionate about this. So if you have any thoughts about this, please email me. Thank you.
Thank you, Hamieda. I really enjoyed what you had to say about the department and your growth during your time there. And you finished off on such an important topic of psychological safety. It's a term I came across this year, and I think this year has been a space where we've had to learn many things, and psychological safety is one of them we've had to learn. So maybe we can move the learnings across the university. I think that would be grand. So thank you. Moving on, next up is Dr. Malibongwe Manono, one of chemical engineering's graduates, but also one of our newest academics, already making a big and positive mark in the department. So Mali is a senior lecturer in the Department of Chemical Engineering. He graduated in 2010, it's a chemical engineering degree, and then worked as a chemical engineer for Mattel and as a lecturer at Vaal University of Technology. We were delighted when he returned to UCT as a contract lecturer, completed his PhD, and has recently been appointed as a permanent senior lecturer in the department. Mali will share some personal experiences as well as some thoughts on the future. Over to you.
Sure. When I was invited by Dave to come and speak in this event, I thought, views from a young academic, what can I say in regards to this department of ours that many of us are very much proud to be associated with. So good evening, Walwyn, ladies and gentlemen. My name is Malibongwe Manono. It is an honor to be invited to speak in this event, which celebrates 100 years of UCT chemical engineering in existence, a department which is a home to many of us who are proud of their association with such a department. So my relationship with ChemEng goes back to 2006, when I came into UCT as a first year from Khayelitsha, having been accepted for the 5-year program on aspect. And I remember then when I saw that people whom we engaged with during the orientation week were as smart as what I would imagine somebody being in the mainstream program. And I therefore asked the then director of Aspect, as well as Professor Eric van Steen, whether they could make a means for me to not register in Aspect, but coming on board in the mainstream program. And that was very much driven by the fact that my maths and physics higher grade marks were well above the minimum requirements. And so Professor Eric van Steen gave me a bit of a scare then when he said to me, well, you have to know that chemical engineering is all about the other things that you may not necessarily have gotten mastery of, such as geography, which you obviously did not do in high school, biology, history, and others. And of course, I learned that along the way as a chemical engineer, how that we have to be concerned about all these other things, which are but not chemical engineering, everything else, but not chem eng. So I graduated, left, came back in 2016 as a young lecturer on a 3-year contract. I must be honest to say that when that happened, that move was a bit scary for me because I had come from a relatively younger academic institution and department where many of us were doing our PhDs, and so we were very much supporting each other in terms of the research that we were doing. And so I thought, I'm coming into a department where most of the people are already at the professorate level. I would just be a number sitting there at the back and not really being recognized for anything. But what I have experienced in regards to UCT Chem Eng is that the senior professorate of this department of ours is very generous in regards to knowledge sharing, as well as sharing experiences that they have heard with industry or even other academic partners across the globe. And so you get tagged along on big projects and you feel the need to just grow as a person. And that's been my experience in regards to, and that not only happens within the research space, but it also happens on teaching and learning, where somebody literally gives you total responsibility for your courses that you teach, but at the same time, you have these great fellows or these great teammates that you are working with who are able to sort of collaborate with you and coach you here and there so as to make sure that you become a better teacher. So the diversity of UCT Chem Eng, when I talk about UCT Chem Eng and its diversity, this is not only on issues of race, but the fact that you're dealing with younger academics versus older academics where there is no competition, but an attitude that acknowledges that we can do better and we can do more when we work together as a team. And so you learn from the older guys, if you like, and that therefore better prepares you as a young academic for the world's complex problems that we as chemical engineers are being trained to solve. So as a young academic, I have certainly benefited more than just the core Chem Eng agenda. And one of the key skills or attributes of this department is very much along the lines of collaboration, collaborate, and collaborate. And this is something that we learn not only once you graduate from Chem Eng, but even during your undergrad years, where you work as a team in the design lab. And I'm sure the undergraduate students who are here in the room will agree with me that people go as far as creating a course called CHE 4000, where people just share all the resources possible. And so that knowledge sharing goes all the way up from undergrad through to the years when you've become an experienced chemical engineer. So I'd like to end off by sharing a conversation that I had with a friend of mine who works in one of the biggest companies within the FSP space. And that person, it was literally on the 10th of November this year. I was like, okay, what a thing to sort of end off my key experience with. And so she says, story time, it's in the morning on the 10th of November. Story time, 8 people in business intelligence were sent on a design thinking course, 3 chemical engineers, a few statisticians, a computer programmer, and a CFA. The portfolios of evidence have been evaluated and only 3 people were deemed competent in design thinking. So she says, which 3 you ask? The 3 chemical engineers, I answer. Coincidence? I say no. And this is why I feel so strongly. So she strongly says, and this is the reason why I feel so strongly about the chemical engineering degree. And I think she then drops a ball which challenges many of us who are young academics within the chemical engineering space. And so she says, it is so powerful. It is now up to you all to ensure that it stays that way. And so on that, I would like to say cheers to the next 100 years of excellence in teaching, innovation, and research. Thank you.
Malibongwe, thank you very much. And you set the challenge high. That's the way we like it. The being tagged along, you need to thank Prof O'Connor for. Prof O'Connor has tagged probably all of us in this room along somewhere to learn something. I remember it happening to me a long time ago. So thank him after this. We're on to our final longer contribution, and that's from Aubrey Mainza. So Aubrey is our current head of department in chemical engineering. He's been in the department for nearly 20 years, and he obtained his PhD in 2006. He's also the deputy director of the Center for Mineral Research. Ah, there are balloons in this room. I've just realized what's going on. So he's Deputy Director of the Centre for Minerals Research. He's Head of Comminution and Classification Research and a Fellow of the University of Cape Town. Prior to joining UCT, he worked as a practicing chemical engineer for Zambian Consolidated Copper Mines. Aubrey, over to you.
Thank you, Sue, for that kind introduction. Deputy Vice Chancellor, distinguished guests, staff present and past, students present and past, and all our collaborators, some watching from within the room and others on the virtual platform. It is a great honor for me to be invited to speak at this historical occasion for chemical engineering at the University of Cape Town and by extension in the country. It is an important occasion where we acknowledge and appreciate the work done by those who contributed to build our department to what it is today. The ethos of the department developed over the last 100 years serve as a reminder of the hard work put in by our predecessors to ensure that we have an elegant department that we see today. But it also signals the work that is needed to contribute by those who are in the department and those who will join to ensure that the department continues to be prosperous in the future. In introspection done after looking at the last 100 years, or what the department has achieved over the last 100 years, that serves as a catalyst for staff, students, and also collaborators to strive to do more, to even reach higher heights. As we move into the future, we will focus on 3 main things defined by the ethos that has been characterized by the department over the last 100 years. And the first that I would like to mention is recruitment and staff development. We recognize that the caliber and goals of people recruited in the department play a significant role in defining the status and the future of the department. We will be deliberate in our recruitment processes by taking on young, energetic staff members and students who can contribute to the unique research and also teaching that occurs in the department by broadening and deepening our scope in these areas so that our research and teaching and social responsiveness will continue to be looked upon with bright lights. We will double our effort to develop our staff to ensure that the department remains competitive and can also be considered as a place which encourages thought leadership both locally and internationally. The second area is consolidating research. there can't be a strong department without research. And the department will continue to use unique, distinct research groupings to organize its research to ensure that we respond to local and global needs, current and future challenges. Therefore, participating in multi, inter, and transdisciplinary research is critical for the department to get involved in seeding technologies that will serve the country and the globe better in future. In this respect, we will endeavor to broaden the research in the department so that we speak to the needs of the country, the continent, and the globe. And that involves being involved in things that harness our contribution to the world, such as 4IR. In this regard, we also want to sustain both research endeavors in fundamental and applied research, because one cannot exist without another and be considered relevant to a university. The third aspect I want to allude to is teaching. The department has continually revised the curriculum to meet the needs of the changing environment. Our current curriculum was revised 6 years ago, and work has already started in the department to look at areas that we can fine-tune or revise the curriculum to speak to the needs that we see in the future, so that we can produce chemical engineers that will respond to those needs and successfully achieve what the requirements for the future are. As shown by history, the department will continually strive to improve and introduce new ways of doing things in order to remain relevant and also competitive in the global world. I would like to conclude by thanking all those that have worked very hard to give us a vibrant department that we have today. But in the same token, I want to challenge present staff and students and future staff and students to also put in the shift to ensure that in the next 100 years, our department has reached higher heights and posterity can judge us favorably.
Thanks, Aubrey. Our department is in good hands. Thank you for that. So we're going to move on. Our time is limited, and I cannot introduce each of those who will give tribute to chemical engineering, but they span 3 continents. They are past staff, students, and sponsors involved in UCT training from the early 70s to the 2000s, and they've come from many walks of career. So our tributes will follow from Prof. Bramie Lenhoff, Prof. JP Franzidis, Dr. Mary Stewart, Prof. Neville Plint, and Dr. Rethabile Melamu.
My name is Brey Lenhoff, and I'm one of the small group who graduated in chemical engineering in 1976. It's a pleasure for me to be able to congratulate UCT Chemical Engineering on reaching its centennial and to thank you for the transformative role you played in my life and career. UCT was where I first started to outgrow my sheltered small town upbringing, and UCT Chemical Engineering not only provided me with an outstanding technical foundation for the rest of my career, but also taught me the importance of having an academic and intellectual community and family within which to function. Most importantly, UCT gave me the opportunity half a century ago, and it's a special pleasure to see that that opportunity is now much more widely available than it was in my youth. So congratulations again, thank you again, and best of luck for the next century.
Good evening, everyone. Greetings from Brisbane, Australia. I'm JP Franzidis of the class of 72, MSc 75, and an on-again, off-again member of the academic staff for 22 years, between 1983 and 2014. I'm so pleased to be part of the celebrations of 100 years of the department, with which I've been associated for over 50 years. Turning through the pages of the terrific book that is being launched tonight brings back to life for me the energy and enthusiasm of the staff and students that made and still make the department such a fun and special place to be part of. Added to that, the versatility of the graduates who continue to have such an extraordinary impact on South Africa and the world in so many different fields. It makes one very proud. I want to thank all the staff with whom I've worked over the years. It was a privilege, and the students who taught me so much more than I taught them, and the university executive for their unstinting support. A special shout to Jim and Jenny for putting together this wonderful volume. You've done a great job. As a recent convert to Netflix, I'm already looking forward to the TV series. Hats off to UCT and the next 100 years.
Hi, my name is Mary Stewart. I'm the CEO of Energetics, Australia's largest and oldest specialist energy and climate risk consultancy. We have offices across Australia with around 70 people working on all different aspects of energy and climate risk, including helping clients manage market risk, helping them deliver decarbonisation pathways, and working with companies to understand both risks and opportunities associated with a changed natural environment. What is extraordinary about Energetics is that with our breadth of services, we have a breadth of degrees. And the degree that is most represented is chemical engineering. Having lived in Australia for nearly 20 years, I have not always been directly involved with the department, though I have always maintained strong links to the many people there. It is extraordinary for me to see so many of the scholarly postgrads that I studied with now being fine, upstanding members of the academic staff. I have made my time available to help with undergrads where possible, and also made input to the Centenary book from the department. I've always been a proud UCT graduate. UCT ChemEng is held in high regard in Australia, and holding a PhD from UCT always stood me in good stead in my work with the mining sector here. But the quality of the degree is just the beginning. What I enjoyed about the department was the camaraderie and generosity of spirit of everyone who studied and worked there. The focus on open working spaces in the design of the department flowed over to the openness of the research teams and the staff. My favourite memory of UCT ChemEng will always be a Muslim friend of mine giving an Easter egg to a Jewish friend. It is this acceptance of everyone, a shared respect and a complete focus on equity and equality that has guided how I lead and manage people to this day. I'm grateful for what ChemEng at UCT taught me, and I wish you all the best for your centenary celebrations and for the next 100 years.
Hello, I'm Professor Neville Plint, the Director of the Sustainable Minerals Institute at the University of Queensland. My association with the Chemical Engineering Department at the University of Cape Town started over 25 years ago while doing my PhD in catalysis at the University of the Witwatersrand, and then for 20 years as an employee of Anglo American, and now in my current role at the University of Queensland. The relationship between Anglo American and UCT has always been a special relationship, in that both organisations took a proactive interest in each other's business and looked for synergies to derive mutual benefit, a true partnership. Another remarkable relationship that has endured is the partnership between the University of Queensland's Julius Krishnitz Minerals Research Centre and the UCT Chemical Engineering Department, working together on the famous Amara P9 project and other industry-sponsored projects around the world. I have been very fortunate to be entrusted with the custodianship of these relationships through my industry, advisory board, and now academic roles. This relationship has deeply enriched my career and indeed my life. The UCT team are incredible and an incredibly impressive group of people who continue to rise to any challenge put to them. The future of chemical engineering at UCT is truly inspiring. Congratulations and good luck for the next 100 years.
Good evening, ladies and gentlemen. I wish to extend my sincere congratulations to the Chemistry Department on reaching a centenary. My name is Dr. Rethabile Melamu, and I'm proud to have been part of the department for 13 years of the centenary, both as a student and as a staff member. I joined the Chemistry Department in the early 2000s as an ambitious but naive 20-year-old. I came out equipped with problem solving and interpersonal skills. It took many sleepless nights, of course. Who can forget the dungeon called the Design Studio in the new chemical engineering building? I know that former students have fond memories of their time there. I certainly do. I also have great memories of my postgraduate years, both from social and intellectual perspectives. Those are the years that shaped my outlook on issues of environmental sustainability and economic development, which have become my area of professional practice. I'm forever grateful for the guidance and the support that continues to date. So to the ChemEng team, may you reach greater heights in the next 100 years. May you continue to equip and shape future leaders that will build the Africa we want to see. Best wishes and congratulations once more.
Well, many thanks to Bramie, to JP, to Mary, Neville and Tabi for those words. And that leaves it to me to move into closing remarks. And I'd like to start by thanking our speakers tonight for their insights, their memories, their challenges and their inspiration. We live in a changing world, but we can see that the depth of the department's history and experience positions us to take it on wholeheartedly. And we like being challenged, so thank you for that. I certainly consider myself, and I think many who have had the kind of association I have with the department, so many in this room will join me in this. I consider myself to be blessed to have had this department at the centre of my academic career, and to have been part of its growth into a strong research-led, real-world centred academic department. We have developed within a changing environment. And in our approach to teaching, in our transition to being more and more strongly research focused, in our response to the changing engineering needs, and in our response to transformation, still work in progress, but a long way from where we were, for instance, in 1990. Of course, it's critical to remember that excellent academic departments can never rest on what they've become and on their strong champions. We always need to challenge ourselves to the next level and to the next challenge. And that's something that chemical engineering has done and continues to do very well. Have every confidence that the department will continue in that vein over the next 100 years. And similarly, every university must challenge itself to the next level and to the next challenge. And UCT is no different. We love being top of the global rankings in Africa, 4 out of 5 this year, and to rank well. And we rank well, mostly in the hundreds. We rank exceptionally well in a number of subject rankings, development studies, mining and mineral processing. I was interested to see that we have 8 from chemical engineering UCT in the top 2% of named people contributing to mining research. Quite an achievement. We rank exceptionally well in the subject rankings. So I was speaking about development studies, mining and mineral processing, microbiology, immunology, infectious diseases, among others. But the rankings don't and won't define our behaviour at UCT, and we need to move to be more than just rankings. So as a university, we've spent this past year defining our Vision 2030, driven by a massive transformative statement of unleash human potential for a fair and just society. We are reimagining teaching and learning, research and transformation, into a strong focus on holistic, innovative, future-oriented education, research solving Africa's problems that contributes to global knowledge, thought leadership in Africa and beyond, and an organizational ethos that supports new ways of thinking, doing and being. Vision 2030 drives to reinvent teaching and learning in a student-centered and technology-centered way, in ways that chemical engineering has been experimenting with over many, many years. Flipped classrooms, technology-aided education, continuous assessment, continuous feedback, etc., etc. We are focusing UCT's research on the many grand challenges relevant to our continent and our ability to contribute globally through unleashing knowledge in and from Africa to redefine and co-create a sustainable global future. To do this, we will build on UCT's many disciplinary strengths and cross-cut these through inter and transdisciplinary nodes, providing the integrated knowledge base to handle these grand challenges. Again, chemical engineering has been strengthening and transitioning into research spaces centered on this for several years now, in clean energy, just transition in the mining industry, value from waste, resource efficiency, nature-based processes, to name just a few of our foci. And throughout, we recognize the need to redress inequality, to return dignity, to amplify voice and agency, and to place the social justice center stage. So in many ways, UCT in its Vision 2030 is catching up with chemical engineering. I can say that with my chemical engineering hat on. I can't really say that with my UCT hat on. So I hope I'm safe here. So I do think that it's an exciting space that we're going with our Vision 2030, and I think chemical engineering is very well positioned to really thrive in this environment. I have every confidence that chemical engineering will rise to these challenges, to the need to balance economic contribution, environmental stewardship, good governance, and social responsiveness as we build new knowledge to underpin the needs and developments of the 21st centuries. And here I support Dave in his drive to us to make the SDGs central in what we do, to make Agenda 2063, the African Agenda 2063, central to what we do. And I think that this will drive our choices of how we educate, how we prepare our graduates as citizens of South Africa, Africa, and the globe, in what areas we build new knowledge, with new processes and new ways of doing, thinking, and being. And finally, how we relate to each other and to our nation and to the world's needs and demands. We're architects of an exciting future. And with that, I would like to just take a few minutes to thank people who've been really important in this celebration. I think first I need to thank each and every person in this room who is part of chemical engineering, who has been part of chemical engineering, and who has been a friend of chemical engineering over the past 100 years. Chemical engineering is what it is because of you. And when I talk about the room, I mean the virtual room as well. So don't think I'm leaving you out if you're not sitting here physically. So thank you to all of you, every single one of you, for your contribution here. I need to thank very specially Jim and Jenny for their work on the book, which I'm planning to thoroughly enjoy later on, and to thank Dave and Siraj for their help in putting the event together. All very important in how we've got here. And then finally, beyond wishing you well in helping us to be architects of
Hi folks, good evening. It's a great privilege to always have the last word, something that happens very rarely in my own life. But anyway, my role here is quite simple, is to tell you a little bit about this publication that we put together as a contribution to the Centenary celebration. Firstly, it's really essential to emphasize that this has been a team effort. Firstly, it would not have happened without the enthusiasm of our alumni, both those who contributed personal perspectives and those who contributed financially to get this project over the starting line. It's been really important for me personally to witness that level of enthusiasm coming from our alumni base. And I entrust to the department the responsibility to develop further means of capitalizing on what I believe is significant social capital. I represent a team of co-contributors, if you will. My co-editor, Jenny Case, is here tonight from the US, and Jenny has provided much needed guidance and to ensure that we captured adequately and accurately the academic development journey that this department has undertaken over the last quarter century and more. I think she's also ensured two important dimensions of this book, that the social narrative is well integrated with UCT's own personal story, but also the broader national story itself. But most importantly, Jenny's a people's person. We would not have been able to put this story together without her outreach to alumni down the years and their enthusiastic response to that outreach. For myself, I chose to initiate this project on the back of a dinner conversation I had back in 2005. So some ideas take some time. The event in question was the World Congress of Chemical Engineering, which happened to be held in my home country of Scotland, in Glasgow. And I had been a plenary speaker and was invited to a table at the dinner with a bunch of global luminaries in the profession, all of whom were nearing their retirement. And without exception, all implored each other to find ways to give something back to those institutions which had set them on their own career pathways. And I took that conversation to heart. UCT Chemical Engineering has been a home for me, both physically and metaphorically, for about 50 years. It certainly set me off on my career trajectory. It's been the root base of a whole bunch of professional friendships and personal friendships down the years. And it continues to challenge me purposefully as we go forward. So the least I can do is devote some of my retirement to helping cobble together this book. So what of the book itself? Well, firstly, I hope you enjoy reading it. And please ensure that you distribute and circulate it as broadly as you can around our alumni base and your industry and professional networks. The book is available in hard copy, as you can see, but it will also be freely available via the department's website in due course. And all donors and contributors to the book will receive their copies as soon as we can mail them out, supply chains and COVID notwithstanding. Fundamentally, though, it's intended to be a living document. It's something where our alumni hopefully will connect to it, latch onto it, and ensure its relevance by continuing to stay connected to the department. And that's my challenge to you. But to the detail itself, you will read, and I quote, "It outlines the evolution of the program and the department. It highlights key personalities who contributed their vision, energy, and commitment to ensure the program succeeded and thrived, and it showcases a range of personal vignettes down the years from alumni, research colleagues, and industry associates." And in that statement is the essence of what UCT Chemical Engineering has been able to galvanize, the relationship from its students to its staff, to its research colleagues, to its industry sponsors. And I think that positions it rather uniquely. It's unashamedly a colloquial social history. It's not a research report. It's not an annual report. But it's our hope that we've captured it in a way that tells an engaging story, that the pictures that are there will somehow encourage you to read the whole narrative. And as much as the centenary celebration tends to be chronological, and Jenny will attest to the fact that we discussed this for a few months, how to avoid that unsuccessfully, we have been liberal in our use of timelines. And just hearing from some of our speakers tonight, you'll appreciate that their contributions cover multiple decades at least. It's great to be part of a department where there's this continuity of leadership and commitment. There are people here tonight who have been associated with the department for 50 years, both physically here in the room and also virtually. It's been essential to correlate the evolution of UCT Chemical Engineering to the climate of unfolding events in South Africa. We would have been remiss had we not positioned the story of UCT in the broader ambit of what was going on in this country. That so many students not only survived but thrived against the oppressive political regime of the day says something about the strength of character of individuals that were drawn to the discipline of chemical engineering. And it's our hope that we've been honest in our account. No one ever said that chemical engineering would be easy. There have been challenges for everyone in this room as a student. And hopefully, as I say, we've captured that with a degree of accuracy, compassion, and understanding. The document also attests to the tremendous commitment that the department has made in terms of academic development and broader transformation initiatives. And can demonstrate, and there are a few bar charts and things in the book, so I beg your indulgence as you read through those, but they demonstrate the significant positive returns that have flowed from that effort. And that was not something that was happenstance. It was a coordinated activity over decades to deliver the success that we can demonstrate. Over the time, the department has enabled the graduation, and I believe these numbers to be accurate, of close to 3,000 BSc degrees, 600 MScs, and 200 PhDs. That's a far cry from 1922, when the first student graduated as the only student of the year. What's good about the book is that we've actually captured the name of every single graduate. I hope we have anyway, over that 100 years. So if you find that your name is not there, I beg your apology, but let's correct that. And that's part of the living narrative. By any measure of academic productivity, the department should take a deep bow. Those numbers are impressive for a department of its size. It certainly punches above its weight, and there are lessons there for other departments of a similar scale around the globe, seeking to leverage what I call their small but agile character to deliver purposeful outcomes. And what's been particularly exciting for me to witness is the growing interdisciplinary nature of a lot of the postgraduate degrees that have been conferred in the last 10 to 20 years. And I think that talks to the sentiments that we've been hearing from other speakers, the need for chemical engineering to deepen and anchor itself in its traditional base, but appreciate its potential to commitment to the wider audience and the agenda that flows from that. But most importantly, these statistics testify to the resolute the commitment of the people who have helped shape this program's evolution. It reinforces the fundamental premise that this department is its people. Without the vision and strong leadership of Donald Carr and Cyril O'Connor down the years, and not forgetting the vision of William Caldecott, a minerals engineer in Johannesburg in 1918, which led to the establishment of this department and program in the first instance, I very much doubt we would be here today to celebrate this centenary. There are UCT chemical engineering alumni scattered around the world in careers spanning academia, industry and commerce, government, and the not-for-profit sector. And we hope that in the book we have captured the breadth of those endeavors and commitments. And I think as a centenary publication, it's really important to reflect on the whole 100 years. And some of us are older than others in this room. Within my own living memory, it's with sadness to reflect on those that we've lost along the way. Donald Carr and Hein Kropholler, who collectively, or together rather, set up the new Department of Chemical Engineering in the late 1950s. Jeff Hansford, who was instrumental in the initial outreach to industry by creating the Industry Academic Advisory Board. Brian Padden, who brought immense industrial experience to bear. Duncan Fraser, who was the anchor and visionary behind the Academic Development Initiative. Granville de la Cruz, who held the department together with his dedication and generous spirit over close to 50 years. And Dee Bradshaw, who in later years breathed new life into the broader minerals research agenda. We hope too that this narrative can assist the department as it moves forward, leveraging its talents to remain relevant and impactful, and to be an agent of change to help address the critical challenges of 21st century living. And it's a particular pleasure for me tonight to acknowledge senior UCT colleagues who are here. And I point specifically to Luigi Nazambini from chemistry. Luigi and his colleagues ensured always through their efforts that chemical engineering students remain committed to their core science base. And that's important because in the history of these 100 years, there were 25 years or so where the chemical engineering program was administered and shaped by the chemistry department. So let's not forget that. And there are challenges that ensue from that. If, from my era, there were 3 or 4 years of chemistry as part of the undergraduate curriculum. Now we're less than 2. So what's filling that place? What needs to be reinstated? Where are the opportunities for improved collaboration? These are all things that are, I think, meaningful questions. Tonight, too, we have in our both live and virtual audience graduates from every decade from the 1950s, many of whom have contributed their personal stories to that narrative, which is over there. And I'd particularly like to give a big shout out to Heinrich Bohr, who's dialing in from California. Firstly, as a student, then a staff member, compadre to Donald Carr, and a mentor to many who followed his path. Heinrich's academic rigor and intellect helped build the foundations that enabled UCT Chemical Engineering to transition to the modern era, gaining confidence and momentum along the way. And if I was to identify someone who was never the head of department, but was fundamental in its existence, development, and promotion, then Heinrich, for me, would be a model to all our current staff and future staff down the years. So with that, please mingle with us tonight, all COVID protocols in place. Share your own memories and reflections of your own association to UCT Chemical Engineering down the years. And let's celebrate what is, to me, a remarkable legacy. So to the next 100 years. Thank you.